This is Algebra 2, Lesson 5.3, Translating Functions. So a translation is a fancy way of saying slide. So we had 4 different function families that we were going to talk about during this chapter. The lines, the parabolas, the square roots, and there was a v-shapes, the absolute values. And the parent functions were always at the origin. But to translate those would be to slide them to different places. And to do that, we use addition and subtraction. And whatever function you have, so f for function, whether it's a line, a u-shape, any of those functions, you would need to add or subtract a value to x, and that would cause your graph to slide left and right. You would need to add or subtract a value to the entire function, and that would make your graph slide up and down. And so based on if you're adding or subtracting, it's going to slide a different direction. And within the parentheses, so by the x, if you subtract a number, it'll actually take your graph and move it to the right. If you add a number, so if we got rid of that minus and made it a plus, it would actually slide your graph to the left. And that's kind of backwards from what we would think, because we know that when we're graphing, the positive x values go to the right and the negative x values go to the left. So that's backwards from what we'd expect. And that's why there's a minus in there, because it's backwards. But the vertical values, the up and down values at the back, that's exactly what you would expect. If we add a value, it'll slide the graph up. And if we subtract a value, it'll slide the graph down. So I just want to quick show which each of these would look like if we replace f with whatever function we're talking about. And this should look pretty familiar. If you think back to point slope form from lesson, was it like 3.3, 3.4? We had the slope x minus x1 plus y1. And that's exactly the same format. x1 is how far we slid it over, y1 was how far we slid it up. H is how far we're sliding it over, k is how far we're sliding it up. The quadratic parent function was y equals x squared. So to amend that, we would subtract or add a number to x. We would keep the power 2, and then we would add or subtract a number at the back. The square root function replacing the f would go right here, and you would have x minus h inside the function, and then your plus k goes outside. So where that line stops, the h should be inside and the k should be outside. What you'll see sometimes is I'll add parentheses to make it really obvious what's inside and what's outside, but those aren't necessarily necessary. And the absolute value one was vertical bar instead of parentheses. And that's about it. So the first example says describe the translation. And when I'm saying describe, I want to know, did it slide left? Did it slide right? Did it slide up? Or did it slide down? I'm going to leave that at the top so I can still see it. Inside my function being added to the x, I have a 2. So if I add a number inside the parentheses, that will slide the whole graph to the left. So this slides the graph left 2. If we want to get really technical, we can say it translates it left 2 or translates it horizontally negative 2, but I'm going to just be simple, say slides left 2. If I see a minus at the back, whatever number I have subtracting at the back will slide the whole graph down. So this also slides down 3. Again, more technical ways could say it translates vertically negative 3, slides down 3 means the same thing. Letter B, I see y equals 4 plus f of x minus 1. So I see a minus 1 inside and I see a plus 4 outside. And that one's not necessarily like the example I wrote at the top. I'm going to start with the minus 1. So minus 1 in the parentheses, minus 1 from x, that is sliding my graph to the right. Anytime we have a number inside, it's going to be left or right. So right 1 translates horizontally 1. And I wrote my format with the plus k at the back, But it really doesn't matter if the plus 4 is in the front or if the plus 4 is at the back. If it's outside of the parentheses, that's my vertical number. And because it's a positive, a plus 4, a positive 4, that'll be up 4. So sideways number is always inside the parentheses. Up and down number is always outside, usually at the back, but it could be at the front or the back. Letter B says, write an equation for the linear function with slope 2 that has been translated to the left 5 units and down 3 units from the origin, then sketch a graph of the function. So I have this at the top to kind of help me. This is the format that I'm going for because it says linear function. So I'm filling in a value for m, I'm filling in a value for h, I'm filling in a value for k. The y and the x, they stay y and x when I'm writing an equation. So that will be y equals, first I need the slope. The slope is 2, parentheses x. Now we are filling in the horizontal translation. So this says left 5, and I know to go to the left, I had it way up at the top, but to go to the left, I need a plus number. It's backwards from what you would expect because moving to the left is in the negative direction. But if we minus a negative, that's why it's a plus. So plus 5 is my left translation. And then it also says down 3, so at the back, minus 3. I'm going to scroll, I think, so I have a little more space to sketch that graph. So I know the regular line, and I'm going to go, maybe I'll go gray. The regular linear parent function is just a line going right through the origin, perfectly diagonal, like a 45-degree angle. So if I am translating that line, I would go 5 units to the left, 1, 2, 3, 4, 5, and 3 units down, 1, 2, 3. So that means that line that originally hit the origin is going to go 5 over 3 down. And so now it's hitting this point instead of that point. And this does have a slope of 2, so that means I need to make it a little slantier than that original line. Doubly slanty? Is that a word? Doubly slanty? So that looks good. It moved 5 over and it moved 3 down. And I have a slope of 2, so it's a little bit steeper. And the last one, write an equation for the transformation shown at right. The quadratic parent function is also pictured. I'm going to scroll up just a little bit, actually. So it says it's a quadratic. So I know I'm going into this format. Because it's a U-shaped graph, I need to have that power 2 up here, but it's the same here and here. So that's, I'm going to put that here. Y equals x, we need something here, squared, we need something here. So the original parent function has its vertex at the origin. And the easiest way to translate a quadratic is to say, where did the vertex move? You don't have to do that. I mean, we could say, where did this point go? It moved here. Or where did this point go? It moved here. But the vertex is usually the easiest point to identify. So if I have my original vertex at the origin, it moves here. That is 1, 2, 3, 4 units to the right. I'm going to write 4 right just to help me remember that. And then it also moved 2 units down. So these are the values that I need to fill in here with the appropriate pluses and minuses. Inside the parentheses is my horizontal translation. So that means my left and right number. I went to the right 4, and right means I need a minus. Outside the parentheses is my vertical transformation, and that is a 2 down. So I need a minus to show down 2. And that is my finished translated quadratic equation. That's it for these notes. Good luck on the exercises, and please let me know if you have any questions.